Give the acid catalyzed mechanism of acetal formation of ethyl methyl ketone with ethanol. So let's write our starting materials. That's ethyl methyl ketone. Then we have the ethanol, and this is going to be the acid catalyzed. So we need H3O plus. You can also use H plus if you want to. That's entirely up to you. But in any case, since this is an acid catalyzed mechanism, this is the acid, obviously, so which means this must be the base. So that's how we get started. So you protonate the carbonyl oxygen, and then comes in the ethanol, because now you have activated the electrophile, okay, which is this carbon right here. So then here, let's move these electrons also. So now you have the OH here, and then OH, ET. Make sure you write your pluses as you're writing the mechanism, so you know the oxonium ions, so wherever the plus is supposed to be. And then also don't get rid of anything until you are absolutely ready to get rid of it. And what I mean by that is this proton right here. Okay, so usually we have a tendency to skip some steps, but don't skip anything. Okay, so here you have the OH, and here you have the OET. Now what we have formed here is of course the hemiacetal. Okay, and so if it was the mechanism for hemi, then we can stop over here, but usually nobody stops at hemi for these ones, so we'll continue on. And so now in this case you have to kind of remember that, you know, I mean, it's not such a huge thing, okay, but still it's kind of important to keep writing the equilibrium rather than straightforward arrows, because this reaction is in equilibrium, okay, and so you can go forward and backwards. So make sure you write equilibrium arrows. So here are the electrons, and I wrote them a little far away. There we go. Picks up a proton. So you have the OET here already, and then here you have the OH2 plus. Okay, so now you protonated the OH, okay, over here. So now once you protonated that, now you can have another molecule of ethanol come in. Now this step that I'm going to write now, this is an SN2 mechanism, so which means everything is happening at the same time. The ethanol is attacking at the same time that the water is leaving, so minus H2O. Don't form a carbocation, okay? Forming a carbocation is very wrong in this mechanism. Most of the mechanisms are proposed because they have been studied, so there's a 99% chance that, you know, everything that is in the mechanism is correct. And there has never been any carbocation studied, okay, in these mechanisms. So please don't write carbocations in this mechanism. So not SN1, SN2, okay, over here. And then finally water. And again, wherever you're using water, you can also use ethanol. That is completely fine. And so here finally is our acetal. And I wrote the ET so you wouldn't get confused between this ethyl group here and the ethyl group that's coming from the alcohol. So let's just look again, okay, for a second here. So we used one ethanol molecule right here, okay, that was to give us the hemi. Then we used another ethanol molecule right here, and that was to give us the acetal. And then the other thing, okay, that you want to see is of course that you lost one water molecule. The water molecule that you lose here, this oxygen, is actually the carbonyl oxygen. Okay, that's the one that's gone. So that oxygen is not there anymore in the final compound. Okay, and so when we study mechanisms of these compounds, these kind of things are studied in there. Okay, so we know that this is what happens.